to find the velocity at point A, given that the roller coaster begins at part B. So what method are you going to use to figure out a velocity at another location when you know potential is measured at the starting location?
Try the Newton's method.
Oh, hello everybody. How are you today? Hi, my name is Albert. I want to welcome you to Geddes' Labs. Today, we're going to enter into the science. Walk with me. Here at Geddes' Labs, we try our best to apply physics to every part of life. So, walk with me on a journey in a way into the dream of a physics student. Oh, hello again. Ladies and gentlemen, we can calculate Julia's velocity with a simple formula. To find velocity, we find distance and divide it by time. If you look at this diagram right here, Julia is running this way. And I don't know what this stuff is, but let's go back to the formula. Distance divided by time, and we can simply find the velocity of Julia.
And we will do the transformation process. Excuse me, what are you doing? What are you doing? No, 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 no.
A word of advice, ladies and gentlemen, never mess with biology teachers.
Whew, I need some water. Now, where should I place my water bottle so the angle is right?
Well, Julia, that is a very interesting question. And it's very complicated. But with the use of kinematic equations, we can find this simply. First, to find delta x, we can use velocity initial times time plus 1/2 acceleration, which is, that's right, 9.81 meters per second squared. That's right, ladies and gentlemen. Times time squared. We can find delta x, which will give us the distance of the water we're traveling.
Oh, perfect. What should I do now? Daddy. Hey, Mr. Cofield.
Hey, Julia.
Mind if I figure out the work of your eraser?
Come right on in and do it.
I don't know how much work it takes to lift this eraser. Maybe the science professor can tell me.
Ah, work. I love work. Let's look at this diagram to figure out how do we do this.
Actually, they're
For
not.
this free body diagram, we have the eraser. The force,
Really?
force is equal to mass times acceleration. But work
That one makes it fall.
is force times distance. So you can take the force you applied to the eraser, multiply it, that is times, by distance, and that will give us work. Work! This is fun. Work is in joules.
No, if it's stuck yet.
That's right, kids. Now go out there and do some work.
Oh, that makes sense. Thanks, Mr. Cofield.
Anytime, Julia.
Why'd he stop?
me, that's it. Fabian Stuchley, rather than begin, I go. Master. Thank you. Good question, Julia. Why did the little boy stop? Well, the obvious answer is friction. Friction is little rough stuff that gets in the way. Because if it was smooth, it would be free sailing. Because of this little ridginess, we stopped. So unfortunately, friction is there.
I wonder how much power is in the lights.
Here we have the light bulb. Now your question is, how much power does it take to light this baby up? Well, we can use this formula, P equals work divided by time. And this may seem simple, but it can be complicated sometimes. Now the unit for power is watt. No, not what, watts. Let me correct myself. Watts, that's what I'm talking about, watts. So when you're at home, you look at the light and see, wow, I can think there's watts out there that are keeping my light bulbs shining bright.
Wow, physics can be interesting. I use it every day in my daily life, and it helps me. And now I can use it to go help me save Miss Geddes.
Julia, I have to agree with you. Physics is amazing. It really is. It's an awesome thing because it's everywhere. Ladies and gentlemen, I hope you've learned a lot from today from our presentation. I hope you can go back and in your dreams, dream big. Physics